Okay, so this video, I'm going to finish what I was saying about the second derivative test. So the first derivative test is this one, and now the second derivative test, I was saying that we need to see what's happening right at this point. So if the second derivative is positive, then what's happening is the function's concave up. So if the function's concave up, it might look like this. And the second derivative test says if the first derivative is 0 and the second derivative is positive, then this is a local min. So this looks like a local min, so this here is a local min. You might ask, like, why does it have to look like this? Maybe it could look like this. But if you think about what's happening, there's no way that the function can look like this and be concave up, right? Because if the function, so the derivative is 0 here at this point C. And if the function was increasing before and is concave up, then that means that the derivative has to continue increasing, right? The derivative is increasing if the function is concave up. And so if the slope is positive here, then it has to be even more positive here. So it cannot be 0 at this point. The slope cannot be 0 at this point. So the function cannot look like this. So the second derivative test also tells us when we have a local max, it's the opposite. So if f double prime is negative at this point C, then we have something that's concave down. And so this is a local max. And unfortunately, if the derivative is 0, the second derivative test does not tell us anything. So if we have a 0 here, if f double prime of C equals 0, then it's not clear what's happening. The function could look like something like this. It could be a local min, but it could also look something like this. It could be neither. You can check, like, if I do x to the 4th and if I do x cubed, both of them have a second derivative equal to 0 at x equals 0, but one of them has a minimum, one of them does not have a minimum or a maximum. If the second derivative test fails, you'll have to move back to the first derivative test. But if you know the sign and it's not, if the sign is either positive or negative at this point, then you can use the second derivative test.